Welcome everybody to Algebra 2, Section 9.3, Complex Fractions. So a complex fraction is a fraction in which the numerator and denominator both contain fractions. In order to simplify a complex fraction, it means that we're going to rewrite it as a single fraction with no fractions in the numerator or denominator. So in order to get there, we need to follow these three steps. First, you create a single fraction in the numerator and denominator, and that is going to be of each fraction. I'll explain that a little bit more as we go through the problems on the next page specifically. Then we're going to set up as a division problem. Then we'll multiply by the reciprocal since it's division. Step 3 is to simplify just like we did back in section 1, excuse me. Then that'll be done. So number 1 here, we have a fraction divided by a fraction. We've been saying for a long time how that is incredibly messy and it's something we don't want to deal with. So now we're going to finally learn, okay, what happens when you have that? And essentially, we skip step 1 here because each fraction, the top and the bottom, are each just one fraction. There's not multiple fractions in the top and multiple fractions at the bottom with uncommon denominators or anything like that. So we go on to step 2. This is a division problem, so we're going to rewrite it as 1. A over 2 divided by a squared over 4. That's what this fraction is saying, is just division. So we're just going to split right there between the two. And then now we learned that when we have a division problem between two fractions, that what we really do is multiply by the reciprocal. So we'll have a over 2 times 4 over a squared. And so this really becomes multiplication and division problems that just look a little different to start. And from this point, now we look to cross reduce and vertically reduce. So diagonally, a and a squared become 1 and a to the first. Diagonally, 2 and 4 reduce by 2 and become 1 and 2. And we end up with 2 over a, or 2 over a to the first. Now you're going to see me skipping this green step and going straight to the orange step very often, to where I just rewrite the top fraction and then reciprocate the bottom fraction. So on step 2, for example, as I skip that first step in the green I did a moment ago, I'm going to skip to the step I did in the orange, where I leave 6 over xy on the top or just in front, and then I'm going to write multiplication, and I know I'm going to multiply by the reciprocal, 8x cubed over 3y. Now I look to cross reduce again. So 6 and 3 diagonally reduce by 3 to become 2 and 1. Diagonally again, x cubed and x to the first reduced by x to become 1 and x squared. And that's all the reducing we can actually do here. So on the top, 2 times x squared, 2 times 8 and x squared would be 16x squared. On the bottom, we have y times y, giving us y squared. So we have 16x squared over y squared. Now, just like we did back in section 1, if you wanted to actually multiply these together first, you could. If you had done that before reducing, you'd get 48x cubed over 3xy squared, and then you would reduce from here, and that would lead you to the same exact final step as you reduce 48 and 3 and get 16, x cubed and x, giving you x squared on the top, and the y squared on the bottom staying on the bottom. So whether you go from orange to green to purple, or just from orange to purple, is your preference, just like it was in section 1. You're going to see me going from orange to purple personally. Number 3 here. So now we're going to multiply by the reciprocal, just like we did to start. So the 18p over 8p minus 2 times 4p minus 1 over 4p squared. Now, we actually need to factor this denominator on the bottom left. There's 2 terms and there is a GCF. So I'm going to turn this into 4 parentheses, try that again, 2 times the quantity, or 2 parentheses, 4p minus 1. That's the only thing that factors here, because the only other thing with 2 terms is this top right of a fraction, which does not have a GCF, nor is it a difference of 2 squares, because 4p is not 4p squared. So now I'm going to go ahead and look to reduce. Now I do want to mention, though, that you're going to see me going from this step to this step, but having it already be factored. And I will be explaining that along the way that, hey, I factored this part of the fraction and got this result. But I'm not going to be writing the orange 8p minus 2 in future steps. I'll be writing the green, just so you're aware. So now I'm going to look to reduce, as I mentioned. So vertically, I see 18 and 2 reduced by 2 and become 9 and 1. Diagonally, I see 4p minus 1 and 4p minus 1 both become 1. And then diagonally again, p squared and p becomes 1, and p squared becomes p. And so as I look at, well, what's left, I say, okay, well, I have 9 times 1 times 1 on the top, leaving me just 9. On the bottom, I have 4 and p, giving me 4p. And that would be my answer, 9 over 4p. Moving on to number 4 here. So as I multiply by the reciprocal, the top fraction, k minus 1 over k, has nothing that factors. The second fraction, the k squared that is now on the top as we flip it or reciprocate it, does not factor, but the bottom, k squared minus 1, does. This is the difference of two squares. So it factors into k minus 1 and k plus 1. If you wanted to show the in-between step of calling it k squared minus 1 in this step, and then in your next step, show the factoring of k minus 1 and k plus 1, you are more than welcome to. Now I look to reduce, vertically, diagonally, you name it. K minus 1 and k minus 1 reduce diagonally, and diagonally k and k squared reduce by k to become 1 and k to the first. That's all that reduces here. So we have on the top k over k plus 1. Quick reminder, we can't reduce this k with this k because this one right here is part of addition. We can only reduce to undo multiplication. Next up, number 5. Too far. So as I look to rewrite this top fraction, the 7c plus 35, the numerator, has a GCF of 7. So I'm going to factor out 7 and get me c plus 5 over c. Then as I reciprocate or flip this bottom fraction and get c squared over c plus 5, there's no GCF or any other factoring that can be done. I look to reduce diagonally c plus 5 and c plus 5 reduced to 1. C and c squared diagonally reduced by c to become 1 and c to the first. So multiplying straight across, I have 7c on the top. And on the bottom I have 1. So I can just put 7c, or I could put 7c over 1. Number 6 here. I rewrite the top fraction, b plus 2 over, this factors, and so will this. So if you want a chance to factor those on your own, now's a good chance to pause the video, and then I'll factor it. So the b squared plus 6b plus 8 factors into b plus 4 and b plus 2 in no particular order between those two parentheses. And then on the other one, 1 is now on the bottom, and b squared minus b minus 20 factors into b minus 5 and b plus 4. So now as we look to reduce, b plus 4 and b plus 4 reduce diagonally, b plus 2 and b plus 2 reduce vertically. And that's all that reduces. So you just are left with b minus 5 over 1, or just b minus 5. Number 7 here. Decided to exit out of my app here for some reason. Alright, so I have what's considered to be a fraction divided by a number. And we know this is considered to be a fraction because, well, it's in parentheses. So what we'll do here is I'm going to rewrite the top, 15 minus 15r, but it's factor out a GCF of 15 and get me 1 minus r. And I'm actually going to call that a negative 15 and make it r minus 1. And the reason why I'm doing that is because I always want the variable to be first, because that's going to match what happens in other places. On the bottom is 15r squared. Then as I multiply by the reciprocal, I might need to know that there's a bottom of this fraction. The bottom's always 1 if you don't see something. So this becomes 1 over 12r minus 12. But 12r minus 12 has a GCF of 12. So it becomes 12 times the quantity of r minus 1. Now remember, if you didn't factor out the negative 15 and you just left this as 1 minus r, you would be completely okay to reduce these, even though it was a 1 minus r and an r minus 1 with each other, and just say the result is negative 1. Anyway, as it stands now, r minus 1 and r minus 1 reduce to 1. 15 and 15 reduce vertically and give us this negative 1. The negative still stays. And this just gets us 1 with the r squared. So as I continue on the top I have a negative 1. On the bottom I have 12r squared. And that'd be my final answer. Moving on to number 8 here. Two big fractions. How exciting is that? As I look to factor this one, I'm going to notice, oh, that has a GCF. So I'm going to go ahead and get ahead of this by factoring out the GCF a step early and calling this 2 times m squared minus m minus 20. If you don't do that early like I did, then it's perfectly fine to go ahead and do it later in the problem and just write another step. But I'm doing that way I know I need to factor this trinomial in the next step as well. So in the next step, that top becomes m minus 5 and m plus 4. The bottom has a 3 as a GCF and gives us m plus 4 inside. Then I reciprocate this one and factor out the GCF on the current denominator, but about to be the numerator. And the GCF there is 9m, giving me m plus 4. Then the new denominator m cubed minus 5m squared has a GCF of m squared, giving us m minus 5. Now as I look to reduce everything, now it's all factored out, either vertically or diagonally, I can reduce m plus 4. I can only do the bottom m plus 4 with one of those two. So I'll choose vertically. If you choose diagonally, there's nothing wrong with that by any means. M minus 5 and m minus 5 reduce to 1. And then here 9 and 3 reduce by 3 to become 1 and 3. And this m reduces with m squared to become 1 and m to the first. Woo! All that to say we have 2 and 3 on the top to give us 6. M plus 4 as well. So 6 times the quantity of m plus 4. If you want to redistribute that 6, you're more than welcome to, but I leave it as is. Then we are just left with the m on the bottom. And that's our answer. Moving on to the next page, we're going to start having to do step 1. So a quick reminder, step 1 said, create a single fraction in the numerator and denominator of each fraction. So like when there's a fraction here and a fraction here, each one needs to have a single numerator and denominator. So we need to get common denominators on these next ones we'll see. So here on number 13, this is the top and this is the bottom. The bottom fraction is in great shape. It's just x minus 3 over x, a very normal fraction. But the top one, x over 3 minus 3 over x, we need to get that into a singular fraction, meaning we need to get common denominators between the denominators currently of 3 and x. So our common denominator will be 3x, so we'll multiply this left-hand fraction by x over 1, or x over x rather, or just x on the top and bottom, and the second fraction by 3 on the top and bottom. So I'm just going to rewrite my result here before I do any true reciprocating or combination. So I'm going to get x squared over 3x minus 9 over 3x, and I'm just going to write it as divided by all of this. That way I go ahead and separate it out. X minus 3 over x. And you could choose to multiply here instead and then reciprocate this. That'd be more than acceptable as well. So now as I continue getting this into one denominator, or one fraction I should say, this ends up giving us x squared minus 9 over 3x. And I'm going to go ahead and multiply by the reciprocal here. And I can continue factoring this. So I'll do so. X squared minus 9 is a difference of two squares. That's x minus 3 and x plus 3 over 3x times x over x minus 3. So now I just look to reduce. X minus 3 and x minus 3 reduce to 1, and x and x reduce to 1, leaving me with x plus 3 over 3 here and here. And that would be my answer. Number 10 is similar, but this time it's our bottom fraction that needs some help. Our top fraction is currently just one fraction, but the bottom one is two separate ones with non-common denominators. So we need to make them the same, which would be PQ. So I'm going to multiply the first one by Q on the top and bottom, and the second one by P on the top and bottom. So I get 1 over PQ divided by q over pq minus p over pq. So as I actually combine those, I get 1 over pq divided by q minus p over pq. Now the reason I didn't turn this into multiplication in this step like I did in the last one is purely because I wanted to make sure I knew what the numerator was before I make it my new denominator. Some of us might get confused if we do that too quickly, and so I like to show it into multiple steps. And then it would then become silly me with my words there, it'd become 1 over pq times pq over q minus p. So you would be more than welcome to go from the purple to green if it makes sense to you, but otherwise just go purple to orange to green if that works best. PQ and PQ reduce to 1, so I just get 1 over Q minus P as my answer. Moving on to number 11 here. Number 11, oh boy, got a little more going on. So this top one's just fine, 5 over 4, cool, it's going to be no issue. The bottom one, however, a bit more going on there. Well, in order to get common denominators here, we need to first figure out what is this denominator really if we factor it out. It's 4 times n minus 4. So our common denominator will be 4 times n minus 4. And this one's just missing a 4, and this one can stay unchanged. So multiply the top and bottom by 4, and then this will be 80 over 4 times n minus 4, I should say, minus 5 times 4 times n minus 4. So then I'm going to have 5 over 4 divided by 80 minus 5, which is 75, over 4 times n minus 4. Now, you'd be more than welcome to once again skip this orange step and go straight to the green step if you would, where we turn it into multiplication by the reciprocal, which is 5 over 4 times n minus 4 over 75. And now I look to reduce 5 and 75 reduced by 5 to become 1 and 15. And the 4 is reduced as well. And so I get n minus 4 over 15. On to number 12. Here, top is no issue, it's a singular fraction, but the bottom has 2 parts. It doesn't look like a fraction, but really, 1 is over 1. So our common denominator is w minus 2 on the top and bottom. And since it's a binomial, I'll put it in parentheses. So on the top, I get w over w plus 2 divided by w minus 2 as we distribute the 1 minus over w minus 2 minus w over w minus 2. So this gives me w over w plus 2. And I often do turn this into adding the opposite. I have it in the last couple problems, but I do enjoy doing that. I think it helps people, myself included. So we have w over w plus 2 divided by negative 2 on the top is due to w minus w over w minus 2. And once again, many of us may want to skip this step, which is fine by me. For some reason I've been calling that minus 2 this whole time. My apologies, everybody. This should have been a plus 2 here because this is a plus 2. I probably caused a little bit of confusion there, and I apologize. So plus 2, so it means this numerator is plus 2, which means this numerator is a positive 2. And the denominator is also a positive 2 on each of these like it was previously. My apologies on that, everybody. So now, as I multiply by the reciprocal, I get w over w plus 2 times w plus 2 over 2. Cross-reducing, the w plus 2 is reduced to 1, and the w and 2 don't, so I just get w over 2. Number 13. Here, I have to get common denominators in my numerator and my denominator. My numerator will have the common denominator of a squared b squared, so I have to multiply the top and bottom by b squared on the left fraction and the top and bottom by a squared on the right fraction. The bottom fraction will be AB as a common denominator. So the left fraction gets multiplied by A over A, and the right fraction gets multiplied by B over B. Whew. So I'm going to have in my top fraction B squared over A squared B squared minus A squared over A squared B squared. And my second fraction, I will have A over AB plus B over AB. Oh boy. So I'm going to go ahead and combine fractions and get B squared minus A squared over A squared B squared divided by A plus B over AB. Now let's multiply by the reciprocal as we get B squared minus A squared over A squared B squared, staying unchanged, and the second fraction reciprocating or flipping, getting AB over A plus B. All right, so this top left fraction needs a factor. Nothing else factors. And so as I factor that, I notice that this has A plus B first, and this is the difference of two squares. So it's going to be B minus A and B plus A. And so we're going to have B minus A, B plus A over A squared B squared times AB over A plus B. And I have to remember that B plus A and A plus B are the exact same thing. They're not opposites at all because you can add any order and they're both positive. So those reduce to 1. And then A and A squared reduce to 1 and A respectively. 1 on the top right, A on the bottom right, bottom left. And B and B squared reduce similarly to where B becomes 1 and B squared becomes B. Because A and B were multiplying together in this numerator and denominator that is just circled, we don't have to reduce AB with AB. We can just do A with A, B with B, because we're undoing multiplication still. So now on the numerator I have B minus A, and the denominator I have A times B. And that's my answer. Next up, number 14. Both numerators have a 1. Or both the fractions, the top and the bottom, the numerator and the denominator, have a 1 there that we're going to need to get common denominators with. So 1 is secretly over 1 for both fractions, and that means we'll multiply the top one by n over n and the bottom one by n over n again, giving me m over n minus n over n. Ooh, too many m's and n's. Divided by m over n plus n over n. Trying to overemphasize. So as one fraction for the numerator and denominator, or for the first fraction and second, before the division and after the division, we end up getting m minus n over n. And the second one, we end up getting m plus n over n. So this becomes m minus n over n, unchanged, times the reciprocal of the second one, n over m plus n. Looking to reduce here, n's reduce, but the m minus n and m plus n don't, because one is subtraction and one is addition. So we end up with m minus n over m plus n. Number 15 here. Once again, the numerator and denominator, the top fraction and the bottom fraction, both need work done here to get common denominators. This denominator, common denominator for the top, will be 4v. So this needs multiplied by v and v, but the second fraction can stay unchanged. I'm going to go ahead and do that work here, giving me v over 4v plus 1 over 4v, divided by whatever we have to do here. Common denominator will again be 4v. Left fraction multiplies by 4 on the top and bottom. Right fraction multiplies by v on the top and bottom. That'll give me 4 over 4v plus v over 4v. Turning these into one fraction each, we get v plus 1 over 4v divided by 4 plus v over 4v. So then I go on to my next step where I multiply by the reciprocal. V plus 1 over 4v times 4v over 4 plus v. As I look to reduce here, I can reduce the 4v and the 4v to 1 and 1, or 4 and 4 to 1 and 1, and then v and v to 1 and 1. But I can't reduce 4 plus v and v plus 1. So I have v plus 1 over 4 plus v. on to our last problem of the day, which is a doozy. So this top needs to be turned into a singular fraction, and so does the bottom. Let's focus on the top first, though. The top here, the denominators are currently a plus 3 and 5a plus 15. We need to figure out what this one actually is so we can get the common denominator. This one is truly 5 times a plus 3, meaning the denominator it's lacking at this point is nothing, but this one needs the 5. So I'm going to multiply this left fraction by 5 on top and bottom. So in my next step, that'll give me 5a squared over 5 times a plus 3 plus, the second fraction staying unchanged, a squared over 5 times a plus 3 divided by whatever we get in the bottom. The bottom, we don't have to factor anything, but our common denominator, this one is missing the 5, and this one's missing the a plus 3 that the other one has each, respectively. And we get 5 over 5 on that fraction, multiplying the top and bottom, and a plus 3 multiplying the top and bottom of that right-hand fraction. So that leads me to get 5a over 5 times a plus 3 plus a plus 3 as it distributes with 1 and gets itself 5 times a plus 3. Now, as I condense these into one fraction before the division and one fraction after the division, I get 6a squared over 5 times a plus 3 divided by 6a plus 3 over 5 times a plus 3. As I choose to multiply with the reciprocal now, I get 6a squared over 5 times a plus 3. If I choose to, I mean that's the actual step, just to be clear, times 5 times a plus 3 over 6a plus 3. So I had to actually factor the bottom right a little bit. The bottom right will factor out a GCF and become, right down here, the top left I should say, I'll just write it again, 6a squared over 5 times a plus 3, next fraction, 5 times a plus 3, and now the bottom factors into 3 times 2a plus 1. There's a GCF of 3 there. All right, so now as I look to reduce here, 5 and 5 reduced to 1, a plus 3 and a plus 3 reduced to 1. Then we end up having 3 and 6 reduced by 3 to become 2 and 1. And so on the top I get 2a squared, on the bottom I have 2a plus 1. And I cannot reduce these 2's because even though this 2 is part of multiplication, this 2 is also part of addition though. And that would be my final answer. And that closes out section 3 of Unit 9 for Algebra 2.